Welcome to Pandey Sir Math class. Children, today I am going to teach you mathematical induction. It is a rule of proving the validity of any mathematical expression. So let's learn how we prove any validity of any mathematical expression for all natural numbers. Here in this statement, it is given that n plus 1, n plus 2 is the multiple of 6 for all natural numbers. Means if you want to verify for any natural number, you will always get, if you are always getting some multiple of 6, then the statement is true, otherwise it is not true. Now, the way of proving is like this. You have to write in this way. First step, let n equal to 1 and then put here 1 plus 1 plus 2 equal to 6. If you simplify 2 into 3 into 1, that is 6, and it is a multiple of 6. So we will write here which is a multiple of 6. Therefore the given statement is true for n equal to 1. Now, you know that there are infinite natural numbers. Okay, so it is not possible to prove for all natural numbers. We cannot prove for all natural numbers. So what will we do? In next step, that is in second step, we will assume randomly that it is true for any natural number. So let's see, in second step, what we have to do, second step, right? First here, let us assume that the given statement is true for any natural number. Any natural number. Say k belongs to n. Means k is your any natural number. After doing this, in next what will we do? We will replace everywhere with n with k. So k plus 1 and k plus 2 we are getting. So we have assumed that this is true for any natural number. Okay, but whether our assumption is valid or not, okay, to support this we have to prove that it is also true for next natural number that we are assuming here. We have assumed here that it is true for a natural number k, and if we can prove that it is also true for the next natural number. So what will be your next natural number of k? It will be your k plus 1. Suppose your natural number is 2, so next natural number is your what? It will be your 1 more, that is 3. If it is your natural number is 3, then next to 3 is your 4. So we have here k, we have assumed here k, so next natural number will be your k plus 1. So now if we can prove that it is also true, the given statement is also true for next natural number, that is k plus 1, then we can make conclusion that it is true for all natural numbers. So say the in third stage, in third step we will use second step expression, that is k plus 1, k plus 2. We will write in this way, third step first, third step. Now we have to prove, now we have this statement, this you have to always write. Now we have to prove that the given statement is also true for n equal to k plus 1 if it is true for n equal to k. That is what we assumed in second step. The second step expression first, write once again, which is your k plus 1, k plus 2. This we can write here 6 lambda because it is a multiple of 6. Okay, that we have already assumed by assumption. Okay, in third step, what will we do? In third step, everywhere we will replace with k plus 1 and with k plus 1. Okay, because we want to prove for next natural number. So we will write here k plus 1, k plus 1 plus 1, that is k plus 2. Write here k plus 1. So 2 is already there, it will become your k plus 3. Okay, now we will express this in terms of this. Okay, and then we will check whether it is a multiple of 6 or not. If it is, then okay. If we break this, what will we get? We will get like this. I am multiplying with this first. So k plus, or we can write in this way also first. K plus 1 is there. Okay, we want this. K plus 2, we want this. And k we have. Okay. Now I am multiplying this 2 with this one. Okay. So k into this means it will give you k plus 1, k plus 2. And then multiply with this 3, k plus 1 into k plus 2. Now this is nothing but the expression that we got in second step. So in place of this we can write here 6 lambda. Okay, that's 6 lambda plus 3 k plus 1 k plus 2. Next, what can we do? We can take common from here. If we take common, then we are getting here 2 lambda plus k plus 1 into k plus 2. Okay. Now, say this is your even number. This is your even number. First term is your even number. Because whatever is the value of lambda, you will always get even number. Okay. If you put any natural number 1, 2, 3, 4, 5, 6, whatever if you put, okay, you will always get what? An even number. Okay. Now next is your, say, if you put here any number, any natural number, because this is your, what will you get? Suppose you are putting 1, you will get 2. Okay. If you put here 2, you will get 3. And if you are putting here 1, you are getting 2, and here you are getting 4. Okay, so thus what we are getting here, even number. And if you try with odd number, that is 2, then it will become your 3 and it will become your 4. So odd into even is also even. Okay, if you write here this into this, odd into odd, you will get odd. Okay, clear? It is not true that odd into odd is always odd. Okay, okay, clear? Because see, we are not going in that. Okay, now since if even if it is one is odd and one is even, you will get even number. Okay, and both are even number, then also you will get even number. If you try, if you want to check, you can check. You will always get a even number, and here it is also even number. Okay, now if you multiply, you will always get, because anything if you multiply any even number with 3, it will always be your multiple of 6. Okay, like 3 into 2, even number 6. 3 into any even number you take, 12. Okay, 3 into 20, you are getting 60. So these all are your multiple of 6. So from, we can say that which is a multiple of 6, which is a multiple of 6. Okay, so thus we prove that it is also true for k n equal to k plus 1, that is next natural number. So finally what you have to write after doing this all, you have to write, therefore the given statement is true for any natural number. Therefore the given statement is true for all natural numbers. Okay, done. So say when we want to prove the validity of like this mathematical expression for any natural number, it is a 3-step sum. In first step, you have to prove for first natural number. In second step, you take randomly any natural number, assume any natural number. Okay, that is called also assumption step. Okay, and in third step, what you have to do, you have to prove that yes, it is true for next natural number that you have assumed next to your assumed natural number. So this is very easy. Okay, there is nothing, only step wise you have to go. So thank you, and please wait for my next video.